Hello, everybody, and welcome to another Woodworking Wisdom. I'm Jason, but I think we know that. So hopefully by now you've got familiar with who I am. Back in the woodturning room, so it's quite nice to cross over again, come back into here, go over a few things. So today, what we're going to look at, some of the basics maybe of woodturning, and we're not on about picking the tools up too much or that sort of scenario things. We cover that quite in depth regularly. This is about the fact maybe you're going to buy yourself a lathe, maybe you have. What can you do when you set your workshop up? Advice I can give you about maybe doing that a little bit. And that's a weird and wonderful little thing. Why do I want to cover that? I've moved house twice, and every time I move house, I have to set up a new workshop. And there have been things that I've learned along the way that suddenly go, why did I do that? So maybe it will give you a bit of an insight of things you could do to improve your turning, get you to understand ways of setting things up. So if you're new to this is for you. Some of the guys, if you've got your lathes and you use them regularly, I'm sorry if this bores the life out of you, okay? But maybe you pick up a few ideas. On the lathe bed, got my bit of paper. Why? Because I typed this all up. I wanted to go through this quite in depth and make sure you got everything. So I'm sorry if I'm reading it off of here, but in reality, I want to make sure it went through in a sequence and we're not skipping too much. All right, so what do you want to make? Let's start with that. When most people get into woodturning, what do you want to make as an item? Do you want to make big stuff? And that's two disciplines on this, isn't it? Because it could be something long as a banister rail, or do you want to make lots of bowls? Now, the scenario, if you start asking that question when you start, can be good. If you don't want to lay with lots of bed length, don't have one with lots of length, because the problem is you walk around it. It takes up space in your workshop. Not good. Don't limit yourself too quickly. So too small a lathe, you soon outgrow it. So think about maybe bowl size. We do a 305 WL, which is a trade lathe. That'll do a 14-inch diameter bowl. That's quite a good size. So think about that sort of size you want to make. Best advice I can give you on that. You can make small stuff on a big lathe. You can't make big items on a small lathe. And that's quite a good thing to think about. What do you want to make before you get going? Okay. Certain lathes, so this is one. We can add a bed extension to. So if you do occasionally want to make something bigger, you can bolt the bed extension on the end, give yourself that little bit more length. But when you're finished with it, you can take it off. The bed extension can also be bolted on different places, so you can put it lower. You gain more diameter. So that could be a good idea, because again, it bolts on and off. Where's your lathe going? Where are you going to put it? So some of us, we start off with that garden shed. You need to think about it carefully. Garden shed, I built a garden shed, and foundations for this need to be rock solid. Maybe 2 concrete walls, you can have wooden bearers going across, but you will need to increase the amount of wooden bearers. If not, everything is going to bounce. And it's quite amazing on how much it bounces. Even if you bolt the lathe to the floor, you could actually get to the scenario the whole shed will move about. And I've been there with that one. All right, so make sure you've actually got enough support for it. You're going to put it in a garage. Great. A bit more secure, hard floor. Hard floor is not always good, because actually it's hard on your feet. Difficult to stand up to for long periods. So could you line that out a bit? So I would put a plywood basin, something to stand on. That also means when you drop your chisels, you don't blunt the chips off of them. Also means the fact it's nicer to softer to stand on. That can be good. Let's have a look. If I'm going to do the PVA, also the plywood on the floor, I will put PVA underneath it, because the problem with concrete floors, they absorb damp and moisture. It will affect your tools. It also makes it a bit damp to stand in. So a plywood layer, but PVA, the underside, would be really good. We can have a laminate floor, something on top of that, something non-slip. But even actually, if you have a plywood floor, if it becomes slippery, you get the mop out, a bit of water, give it a wash, it will raise those wood fibers again. So that'll make it non-slip. Power supply to this. That's a really great one. And there's sort of stories we could give you, history of here, different things. So power supply, make sure it's got its own supply if you can. When you start off, I know you're only going out there occasionally, get going. If you like this as a hobby, get yourself rigged up with your own power supply. But there's nothing worse than blanking out the whole of the house just because you've done something in the workshop. And I've been there with that as well. And there's nothing worse in the middle of winter where I trip the whole house out and the wife comes out and says, dinner's going to be late now. You obviously turn things off a bit. So think about your power supply. You can never have enough sockets. So think about where things want to go, your layout. Also think about things like extension leads. If you've got your garden shed at the end of the garden and 2 extension leads, you get power drop. You lose a percentage of power over that cable. Actually, on something like an electric variable speed lathe, it can be a bit detrimental to how it will function. It won't start or stop properly. All those things can play a part. So try and stay away from those. Can you insulate it? Frederick, you did a greeting yesterday. It's cold in Kent. You've been in the workshop for a couple of hours. Can you insulate it? That's a great thing to do. Now, my workshop has 2 layers of plywood now. Insulated walls, so 2 inches of insulation, a plywood skim on top so I can bolt everything to it. I have insulation in the ceiling. Took a little bit of effort, but it keeps me warmer. It also keeps it cooler in summer. Stops my tools going rusty. So all those things add up. Takes a little bit of effort, I know. Okay, so quick one there, insulation. Natural light is better than anything to work in. So if you can have natural daylight, can be great. Putting your lathe next to a window isn't always fantastic. Now, Ben sat here laughing because he knows the story behind this. One of my more elaborate boxes has a glued up section as a line down the centre. Well, let's just say in the middle of winter last year, it came apart on the glued up point, came off the lathe, and it made a bit of a crunch noise and it went through my window. So I had to replace the glass. I then had to decorate my window. Okay, so go on, Ben, let's have a look at the picture. What did I do with my window? So over my window, just to protect it, and I'm sorry, we couldn't turn the picture around, so you need to lean on your left shoulder as you look at this. I put a wire mesh over the window. Okay, I took the picture in the wrong aspect on my phone to get into here, but I put a wire mesh over the window. I can unclip it and take it off when I don't want it on there, but it just stopped anything hitting the glass. So if you're going to have your lathe in front of a window, try and think about protecting it, because there's nothing worse than breaking the glass. Okay, so we're done with that one. Great. If you can have a skylight in your shed or plastic roof panel, fantastic. It will let natural light through. That can be really good. All right. What about lighting? When I started my workshop that I've just got now, originally I bought strip lights to go in it. But newer things have come in. So now I actually have LED panels. It's so much better. I find them brighter, a better type of light, a more natural color, and you can get different colored LED panels. So go careful on what you buy, but look into it a little bit. So LED panels are really good. Now, the other things I hadn't thought about with LED panels, first of all, they're slimmer, not as much thickness. So your head height up here, not going to hit those lights. They're more cost effective to run. So they work better. You don't get a strobe effect of almost flashing, which is what a fluorescent tube does when you're working with it. So it's clearer to work with on a lathe. They don't break as dramatically either. If you actually hit a fluorescent tube with something, I've done that. I turned a piece of wood over, smashed the tube. It's quite spectacular. So LED panels are definitely a lot better to go with. If you want separate lights on the lathe, we've got things like the Bandy LED one here. We love this in here. I don't know if you can see how I can turn this up and down. It's got a variable dial, so I can move that. I can obviously bend it around, go to different places. We can alter that bit. Really good to get it over the workpiece, maybe inside of a bowl. You want to see what's going on. A bit like that we've just had in. We had questions about this the other week, and we would just bring them in. I didn't have part number. We have this ball light, and again, I put this on the list. I've got one of these at home. Colwyn's got one of these. We bought these at Makers Central about 4 years ago when we went. I really like them. So finally found the supplier and kind of said, can we deal with? So nice thing with this, we can clip it onto the lathe. It's magnetic on the base, so I could put it to there, bend it. And again, it's getting light into maybe where you're working with whatever project. So inside a bowl or something can be really good. If you're doing things like your pyrography, you can put it on the stand, put it on the bench. So you can move this one about a bit easier. So that can be really nice to use. And again, with it being LED, easy to do. It's rechargeable. How do you recharge it? Your iPhone socket plug that you plug into the mains, you get a lead that goes into there, you plug the ball into that socket. How easy is that? Don't have to plug it into the computer, so makes it nice and easy to do. But lighting is such an important part. All right, makes you see easier. Everything else, noise. Got to think about this, and this goes back to the installation thing. Try and cut down the noise level. Believe it or not, yes, it does. It makes some noise when you're cutting. All those other things, they affect it. Other things, if you go back to the electric power, you might start off just with your lathe and it suddenly grows. So that makes more noise. You end up with an extractor. You get a bandsaw. You got your bench grinder. You might have an angle grinder with something on an Arbortech disc or something. So all those little things add up on what's going to make a lot of noise. So installation will help cut that down. But think of the neighbours around you and how much noise you're possibly making. The more weight you can add to the lathe is a real important consideration. And it's one of those things most of us don't think about. First of all, what type of lathe you're going to have. If it's freestanding and you can put it on the floor, it'll be more stable. So if it has a stand that goes onto, fantastic. Most of the stands you get like that have something of an adjustable foot. So we have this thing on here. Right, this is adjustable foot of one of the lathes on the machine. So I have 2 nuts, 2 washers, adjustable bolt, so I can level things out on the lathe as well. That's important. We're going to look at that a little bit as we go on. But the adjustable feet on each corner of this lathe stand, I can adjust for height. And it's better to use the adjustable feet than it is to bolt the lathe to the floor. If I bolt the lathe to the floor in here, yeah, we might be all right. But actually, if I put something too out of balance on this lathe and I bolt it to the floor, I reckon I'll pull the bolts out the concrete. Adjustable feet, I can level out and control it. So one of those scenarios. If you've got a workbench set up and you've got a mini lathe on top of it, that lathe's only as good as the workbench you're putting it on. So in reality, if the workbench isn't stable or strong enough to take the weight and it's going to move about, it's going to cause problems. And when we get to the wood in a minute, when we start looking at a few things about, wood actually has that inherent problem of causing those issues. So you've got to make sure things are nice and stable. So you're going to have a workbench, make sure it's going to sit on there accurately and be bolted to the workbench. But the workbench has got to be fixed in reality and structurally sound to take that weight. We do something like a 1000 lathe, which is similar to a picture that I've known of for quite a few years. This picture has a great way of adding more weight to your lathe. The more weight you can add lower down, the better. Okay, so by adding the weight lower down, it helps support it and dampen everything down, stop it moving. So similar to on a 1000 lathe we used to do, or we still do, the jet lathe, we've got a picture there, we used to do a 900, 950, they have a press plate steel stand, but to add more weight lower down, I think that's taken a little bit over the top, but it definitely works. Lots of bags of cement or sand, really good. My lathe at home actually has a hollow leg stand section with a bolt on side. So inside there now I have 2 plywood boxes. Those plywood boxes I can fit into the stand. I can take them out if I need to. But inside those boxes, they are filled with sand. So the sand is adding more weight lower down near the base. So it's making it more stable, stopping it moving about. All right. So other sensible things. If you've got a bench top lathe and maybe you want a freestand or stand to put it on, we do a little black stand. All right. Now this intrigued me because first of all, it's adjustable. So Ben, let's have a look at that little black stand. We'll bring that one up so we can adjust the height, the width, depending on what lathe it is. Now I also have a friend who has one of these, and I was quite intrigued when I went up to go and have a look at this because he's kitted his stand out and I'd never thought about this. So he's done that. So he put plywood on either side. He has centers that go into the top. The plywood either side, he's made his tool rack on. On the back of this, he's got a rack that holds his chucks, face plates, and all the other bits. So he's added more weight by actually then using it for storage as well. Fantastic way of getting over that issue of, okay, so it adds more weight, increases the storage capacity. So he's actually using it to the best advantage. All right. So think about how you're going to do that. All right. So we've said about building shelves in. You put your cement on, your sand. Okay. Just going to go one bit of paper over there. I mean, just going to, so wherever you go with, you need a certain amount of room around that lathe. And that's something we tend to forget. So my first lathe, and I'm just going to set up a bit of a scenario of on here. Now, I've just brought in a pine plank that I can stand up. Ben's got the picture there, so my bit of pine. This is indicating my wall that was on my first shed, if you like. I then get my bowl gouge, and I want to hollow inside the bowl. I want to get nearer the middle, but actually the only way I can do it is bring the chisel back more in line with the lathe. Doesn't help me. I need to bring the handle out. So if you limit where you are, the wall gets in the way. Can become really frustrating, especially when you're new to this. You put something together and you suddenly realize that the workshop environment that you're trying to fit it into isn't going to take all this. So you need to think about what's found here. So space can be quite an important part. Some lathes are built, if you like, to help do certain things. Swing head can be fantastic. So on here we can move the head round. We've got more access. We've seen Cole in the last few weeks when he's following his bowls. Get them out here. He can stand here facing the lathe, which is easier. If you have a long bed lathe, maybe without swing head, you've got to stand right on the end, right down here. First, we've got to lean over the bed. That could be tricky. Or you've got to lean over the side. Bit more uncomfortable. So swing head can be a great idea to give you more access to get into there. Right, just go through. Other thing, just going to do this one, but this is going back to that restriction of where you are in your workshop. Other space you need. And again, I've done this. My shed wall out here, put my lathe in situ, can't get the knockout bar in to knock the drive centre out. Nothing more frustrating when you start off with. You've got to have a certain amount of room. So something out your knockout bar has got to go in, allow you to get those centres out. So if your wall that you've got out here is blocking the end of the headstock, that causes quite a restriction. Okay, I'll pick my bit of paper back up. I think, Ben, just checking where we are. So we said about swing head, extra access, down at the lathe. Okay, let's go what you've got then. Come
on. So I've got a couple of questions here. First one's from Robert. He's changing the subject slightly, but he wants to make a Lazy Susan.
Right.
Do we know which is the bigger diameter, the base or the top?
Doesn't actually matter, but I would normally have the top as the larger. And you will need to, if you have it already and it's the bigger round one that we do, you'll find there's one bigger diameter hole. So you need to, from memory, mount it onto the base, but drill down through one of those larger holes. So you go, have one hole in your base and then turn the base over, put it into your top and screw that on. So you have one hole in the base unit that allows you to screw the top onto the base once it's done. So you can join it all together. All right. Hope that makes sense. All right. Ben?
And then this from Cliff. With the fixed thread sizes on the head unit or the spindle, are they changeable? Could you upgrade for a different chuck? So if you had an 1.8 thread,
we're going to get to. Okay. So Cliff, I'm going to cover that in a minute. We're going to go through and I'm going to explain some of the issues for you. So that can be an issue. Okay. All right, Ben.
And then we just had a really good suggestion as well for the feet. You could use hockey pucks and threaded rods.
Could possibly. Yeah. Okay. All right. I'm glad to know they're thinking about this and even watching. Okay. All right. So lathe height. Where do things need to be? Your center point, if you put something into your center of your lathe, something that's not sharp, I'm going to go with light pull drive, just the fact I know it's not sharp. When you set it up, your elbow point needs to be level with the center of your lathe. Okay? And that's quite an important part, getting that lathe height right. I actually saved for a few years. I did a course when I was about 13, 14 years old and wanted a particular lathe. I saved for 10, 12 years and managed to buy myself one. But when I was about 14, I was obviously shorter, which by the time I got to that age, caused me a few more issues. And to me, to use that lathe, and it's a Harrison graduate short bed pedestal lathe, and we had to do a few things to fit it in and get it working properly. I ended up having to put a concrete plinth onto the floor to raise it up. So I ended up backache turning everything there because the centers were too low. So suddenly had to try and raise it. So think of that height. It's quite an important part that you get your height right. Likewise, if you put a mini lathe on a workbench, it's suddenly up here on some of them. We measured one the other day with the 350 that we do as a craft lathe. We found just a little bit too high. So you might have to put a duckboard on the floor. So almost like a pallet that raises you up a little bit. Think about that. So your height wise, ideally elbow height with your arm bent just across your body, right? So a bench lathe we said about limiting use. The other problem with putting a lathe onto a workbench, if it's your workbench you're using regularly, it ties it up, limits what you can do about it. You've also got the problem, especially on the cast iron lathes, as much as they are portable, they're quite chunky to lift. So you've got to think about where you're moving things about. So try not to go moving things about too much. So we said about stand adjustable feet. Now, why is that important? Now, on the lathe we have here, we need to get things level. All right. So center points. By adjusting the feet out, I can actually twist the lathe bed, the cast iron section on this lathe. And you wouldn't think it's possible. We've done it, we've played with it, it's quite interesting. I wanted to do it as part of the video, but it's difficult to get all the focus on from where I am crawling around the floor and getting this set up. So you need to level those feet out. Likewise, if you have a workbench setup, and my first lathe had a workbench setup of 2 metal plates on a stand and a long pine board. Now the pine board twisted as it dried. That twisted the lathe a little bit. So even things like that can play a part in it. So you might need to double check something. Your centers ideally need to line up. Now, not 100% critical, but it is better if they do, especially if you want to do certain disciplines. Pen turning can be a really good example. So if I put my centers in, I'm going to bring the tailstock just up into play, just bring the barrel up, put the mandrel at the other end. If I turn the mandrel over by hand for you, it should run true. Just taking the lockout pin, let's move that. Shouldn't go moving up and down, should be nice and true. If we bring the tailstock up, that should line up. I'm just locking headstock back in. So they go in. Now this has got swing head. If I drop the pin in, the further, I'm just going to bring back just a touch. The further down my mandrel I come down to the bar, so this end, the more movement I get. Now there's probably 3/8, 9mm movement there. Not so much this end because that's your fixed point, but the further down this bar we travel, the more movement. So if I'm going to set this up for pen turning, I'd want to line it up and check it. So as I tighten this down, it pinches over a bit. I might need to play around, and I want to be able to wind the tailstock onto there without pulling anything about. So in other words, I'm not pulling this bar over to make it go into the hole. I want it to line up by itself. So I've got to adjust that head. If you can't adjust the head as in a fixed rotational head, like we've got on here, you might need to play with the stand. If it's got 4 bolts on the headstock, so definitely the benchtop type lathes, slacken those bolts off, there will be a little bit of play. So it can be worth looking at. If you're going to use a drill bit on the lathe, it's important because it will help obviously line that drill bit up with the center. But definitely the pen turning, most problematic area, lining things up. Adjustable feet we've got. Bottom lathe down, we're done. Just checking we're not skipping too much. All right. So things you need to know about your lathe. And this goes back to, if you like, to my shop history. So when I worked in the shop, there's nothing worse than the customers come in and going, I bought a lathe. And you go, yeah, okay, what is it? Don't know, it's blue one. And that was one of the answers. And at that point, you start reading off these names of lathes that could be blue, could have been blue. Oh my God. All right, so, and he still didn't know. So first thing you need to know, Morse taper size. What is that? A Morse taper is this section. It fits into your headstock and your tailstock of the lathe. Some lathes have a threaded nut that fits on, so you can't use the knockout bar through the back of the headstock to take it out, but they will have size. There are 8 sizes. There are only 3 sizes in wood turning. Number 1. Okay. And we have more number 1 products coming back into stock for you all. All right. So number 1. 2, probably the most common. I'll fit in here. 3, I have a sleeve. All right. I can't find a 3 Morse taper at the moment. My graduate that I had was 3 Morse taper headstock, 2 Morse taper on the tailstock. Frustrating. Okay. Very unusual that you're going to put something in, but there are certain scenarios. Drill check's probably the most easy to suggest. There are ways of just using a sleeve. So the sleeve will fit on and secure it. But you need to keep things clean. If you get a line of dust inside here or some wood shavings when you put it in, it will affect how it runs, and it will run slightly off center. Okay. So first thing's your Morse taper. All right, Ben.
So a question here from Fuller. How does one correct slop in the tailstock?
How does the...
In the tailstock, if you've got a bit of movement, a bit of slop.
Okay. Difficult to get over. And this is a weird and kind of wonderful. You might be able to use some, and it depends on how much movement it has. So this is metal strapping. We have plastic strapping that comes out on some of the pallets, but it depends on how much it has. But you might be able to glue that on the side of, and most tailstocks have a casting that has to fit over the bed. Shouldn't be too much play. And best advice I can ever give you, don't go filing material off it. Don't go altering it. It should be pretty accurate when you get it. So if that's not accurate, then maybe you need to look at ways of increasing the accuracy. But if you start filing stuff about, you're going to deviate even more. Check the feet can be a thing. Other thing, occasionally I've had a bit of movement on the barrel. And my lathe at home, where it's now 20 odd years, got a bit of slop on here. There's no way of me tightening that up slightly. So it's... But you want to make sure. Other thing, if you're using your tailstock and trying to think of scenarios where I've had this, it's worth locking up that side handle. Coming up. No, you don't need to swing on this and really lean on it and get too much pressure on it. Just pinching it tight will give you enough. But actually, that makes the difference between this rattling a little bit and fixed in place. So that can be a good technique. So pen turning could be a good example, because if you don't lock it, you're going to get a little bit of wobble on here. That's going to cause a wobble. If you lock it down, you're fixing it in place, basically clamped in place. So even something like that can make a difference. If you have lots of movement underneath, though, you might need to tighten it up. So something as a shim in between that you can bond on. Aridite epoxy could be good to stick that on. Okay, so hoping that helps. Difficult, but go careful with that, because you can offset stuff too dramatically one side. Okay, so we said about Morse tapers. What about chuck bits and faceplate? Let's do faceplate first. Faceplate, what's that? That screws onto here. That's a primary holding device. And know that word, primary holding device. It's what you're going to use to fix your bowl onto, or your piece of wood to mount it on the lathe to do the initial turning. Now, going over some of the issues we also get, if you like, with servicing department, we've had people complain, my faceplate's not 100% flat. We measured one, the guy did complain his faceplate was something like 2 thou out. How does he know it's 2 thou out? Okay, he puts, okay, well, it's a faceplate. Doesn't actually matter if it's not 100% flat, because the piece of wood that you're possibly going to put on it, and this is a piece of oak, looks okay, doesn't it, guys? What do you reckon? All right, let's have a look at camera 2, I think, as well. What do you reckon? All right, not too bad, is it? So if I put my faceplate on here, now remember, he complained the faceplate wasn't flat. Now, what do you think of my piece of wood? So how are you going to do this? What are you going to do to flatten this out? Some of you might plane it off. Some of you might go, I'm not buying that, or I don't want to use that. This is how timber dries. Naturally, it will distort. This is from cut, what I would class as a crown board near the edge of the tree, cut into planks. And as it dries, it will dry to that cupping. So how can we level that out if we want to turn it? Real simple and easy ways. This has got to be the top of my bowl, the inside. We've got more cracks underneath. Nice. Washers. You could put wooden wedges in, but actually, I like using washers. Now, if I was going to fix this down, I would do a screw parallel to where my wobble is. I can then start to use some washers, and I can put a screw down through the hole in the center of the washers. So they are fixed in place. They cannot come out when it's going round. So I can level things up using washers, and this is a technique I regularly use at home. Actually, I was on a bowl last night and working on some monkey puzzle, so I might feed those in and screw down. So these two screws will fix it in place, and I don't go mad and over tighten them to start with. Fix these in, put it on the lathe, check how much wobble I get here. You're going to get a little bit, but you want to try and level it up as much as you can. I can play around with those washers to level things out as much as I need. Real simple, easy way of using a piece of wood that's maybe a bit warped or dried to a wobble, but flattening off using something easy to get hold of. The other major thing with that is safety. So by putting the screw down through the center of the washer, it's locked in there, it can't come out and hit you. If you put a wedge in and you tap it in, then tighten it down, not always as secure. So quick and easy one, that one. Right, let's get that back on there. So we said about faceplate, need to be flat, but think about it, it's a primary holding device, doesn't matter too much. Chuck. All right. So to answer that question we kind of had, let's see what we got in here. Chuck adapters and thread adapters. My best advice I can give you, if you don't need to, don't. And that's quite strong worded, isn't it? Now, the problem with this is if I put this onto here, we've come out now 2 inches off the spindle. I'll then put my chuck on those screw arm. Now, first of all, I'm increasing all the weight on the spindle off the bearings. I'm lengthening it a long way off of my bearing point. What I'm just going to try and do, bring the headstock in a little bit. So we're here, coming up a long way off of there. The more I come away from my bearings, the more leverage I'm putting on, so the more weight. The other problem, if you look at how a screw thread works, it pulls everything at an angle until it comes up to a registration point. So this being the spindle, could be the block, could be a register on the back here, those keep it square. But the more discrepancies you start to bolt onto your chuck, the more risk you have of it starting to be out of line. One of the reasons with our chuck, when we started doing what we now have as stock, they are direct threaded, no inserts or back plates, is the fact it's more accurate being one piece than having two components that bolt together. So it's all about trying to increase the accuracy. So if you don't have to use a thread adapter, don't, okay? Because it will cause more issues. All right, other thing while we're looking at that, I'm going to put the chuck back on. How many of you got your chuck stuck on the lathe? Or your workpiece stuck on the lathe, your faceplate? Chucks are a good example. Now, normally you might have your chuck stuck on the lathe. You need to figure out how to get it off. First thing I would suggest is take the work out of it. Try not to go clouting things with hammers. So even if you put your key into here and you lock your spindle, try not to beat this with a hammer. You're going to damage things. It's the wrong directional force you're trying to use. On this lathe, and I'm going to lock the spindle, take the chuck back, throw it on. I now will struggle to push that off freehand. If you've started the lathe and you wound it on, going to be problematic. So how do I get this off? Camera one, I think, Ben. So I'll go find something with a rectangular bar, a clamp. You have your keys. You're going to need to take your bit of work out that you might have in there. Just going to bring this open a bit. I've got to get my arm up a bit. Okay. Open too much. Got my angle a bit too much on the chuck. Put that in. If you can, lock it off. So I'm clamping the jaws now down onto that bar in the clamp. So it put the jaws under a tension so they're gripping. Then I can use that clamp. Right, I can use the weight and the leverage we're going to get off there. So much easier to do than hitting your chuck key or taking a hammer to it. Next thing that I would suggest, though, if you're worried about that happening, how about getting one of these? Okay, nylon washer. Fits on. That'll produce a cushion area, if I can get it up over my register, onto there, help your chuck come on and off. Where do you get your nylon washer from? Where do you reckon, Ben? What do you reckon this is? What am I like? This is milk carton. So the guys in the UK, the guys in the States don't know, we get lots of plastic milk bottles these days. I love using this sort of stuff for things like this. So all I've done, cut out a section, put a screw in the middle of it, screw it to a scrap piece, turn the shape I want. So easy to do to give you a softener. Okay, let's just whiz that back off, pull that out. Ben's got another question.
So a question here from Sol. He's got some wet shavings on their centers, and it's discolored them. It's given it a patina overnight.
Okay.
Is there anything they can do? A suggestion here that they should they sand them back?
Okay. Now let me guess. I bet the discoloration you probably got is black. It'd be interesting to know the material. If it's oak or something, the black will go into the metal slightly. You won't get rid of it totally. Worth noting now, if you're using wet wood, clean the lathe bed at the end of it. I did this whole scenario last night. I'm working on a monkey puzzle bowl. It's about 12 by 12, all end grain, wet. I had lots of resin spots on my arm last night, and I'm actually having to pull the hairs out to get the resin spots off. All right, fantastic. So if you've got lots of muck on here, we can clean it off. So even your polishing and everything else you'll do, so you could use scalpel blade or something, scrape it. You don't want anything's going to cut it too much. Other thing then I will use is, I think it's down the box down here, Garaflex block. So this is rubberized abrasive. We can dress the lathe bed. If you have an orbital type sander, you could go with something like a 240 grit and you could sand the bed. That'll work. Help protect it long term. Let's get a little bit of a blue roller. The other good thing to use with this could be web racks, synthetic steel wool. So this is machine wax. Do bigger tins of this. You need to also do the groove down inside where your banjo is. Clean that because that gets lots of resin and gunk. Your waxes, your sealers, all of that collect on there, can cause real issues. So your machine wax, I would put on, buff it up. First of all, it's going to make things move easier. Woo, that's good. Glides really nicely. Okay. It will also stop other things sticking to it. So, in other words, the discoloration. But my best advice I can give you with that discoloration in your lathe bed, when you finish turning, have a clean-up session. Get it off of the raw metal, as in steel. Also, if you've got something which isn't a stainless steel or chrome body chuck, try and make sure you clean that out. It can, especially oak, make stuff go black very quickly. Okay? So, where are we there? Morse type we've done that. Swing headstock we've said about better access. Speed. Let's get to that. Speed is the #1 rule for wood turning. And you've got to remember, if you don't, it can become very dangerous. Now, there are three types of lathe you can have for variable speed. Okay? Manual belt change. So I'm just going to bring the headstock up again. Just looking on camera for a minute. All right. So, manual belt change. We do, I think, one lathe that's still just a belt change. This one will just open it up. So you have your belt in here. You can have mechanical variable speed, which still has 2 pulleys, but they are spring-loaded and they open and close. You move a lever on here, and it gives you more speed than you would get with a traditional standard belt change. You can also have this magic thing called electronic variable speed. If I bend my light back, So Ben can bounce between camera 2 and 3 in a second because we have a dial and I could never go back to manual belt change. Electric variable gives me the scope. I can go on, I can dial things up and down. These have a 3-phase motor, so it makes it quieter, it's more reliable, single-phase supply. Straight to the mains. I can get my speed, I can dial it up. So we're now running 3,650, all right? So 3,665 down to 0, okay? Take that off of there, move my chuck key. Now, if I turn lathe off, go to there, got that on, undo there, move it, we still have this as a belt. Well, this is really important. For those of you that have electronic variable speed lathe, why do we have a belt? Now on this belt setting, I can only go up to, have a look. So I've got 1345, okay? I can come down to 0. Probably stop at about 50. Now I can try and stop this with a hand wheel. I'm never going to stop this. Now I put it on the lower setting. Now depending on what you are making, you'll determine where you need to have your belt. So this lathe will do, I think off the top of my head, about 16-inch diameter. Just fiddling, change the belt round. Get it off there again. Slide it over. Now a nice thing with this is a lathe, I haven't got to crawl around the floor, change that belt. Done. Back onto the fast speed. I can bring this back round. Take my lead back over. Pull the chop back. Get to there. So we're now back on the fast speed. Quite quick and easy to do. But why have a pulley system? It's electric variable. I can go from 50 up to 3,750. Why do I need that lower setting? In simple, and it's something that not everybody still seems to understand. I've even been to club demos and you don't need to change the belt setting, it's fine, it's electric variable. No, I need to get more torque out the motor. So in simple, you will get in a car, you drive it. You don't try and pull away in 5th gear or drive up a steep hill in 5th gear. You need to use the gears on the car to get the best torque and performance out your car. Same with your lathe. So if you're doing something bigger diameter bowl, so I would say something 10 to 12 inch on this, I might put it down on the slower speed. I will get more torque and drive out the motor. If you use the lathe and you find you're doing your bowl and you're getting the chisel out nearer the edge of the bigger diameter and it's slowing down, the inverter can't deliver enough power, keep it turning for you. So you want to drop that belt setting down to get more torque, more drive out the motor. Also prolongs the life of your inverter for you. Okay, Ben.
So a question here from Daniel. He has to use a thread adapter on his lathe.
Yep.
And there is a little gap at the back of the chuck to the register. Or the
so on the thread adapter or on the main body here? If you don't know, it's not going to matter too much because they're both the same. Ideally, it should fit all the way back because your registration point on here is actually that square shoulder and that step. You want to make sure it's coming all the way back onto there. So you get that flat and the step, those two should come together. All right. Whatever it fits on should be hitting back on there and on your register. So if you're getting a small gap, think about what's causing it. It could be the register's too long, could be the registration point, the step's too long, could be overall too long here. You might need to find an engineer that'll skim a little bit off the front, but measure things before you dash it out and say, I want a bit off here. So you get something like your vernier, you can measure your depth here. Check there's nothing that's going to affect it measuring down inside there. So I can use the vernier, the long bit. I can adjust how much, check your depths, check it. All those little things make a difference, okay? You might be able to use something like the nylon washer on there. That could be good. All right, that would help. Ben?
Sorry, that's what I was going to say. Could he use a washer?
Yeah, he could use that nylon washer to fill that gap. That'll help it sticking, or stop it getting stuck on the lathe. Oh my God, the thread adapter done. Ooh, So we've done about speed. Electric variable is definitely the better way to go if you can afford it. The other nice thing with electric variable, you can go anywhere. All right. So next thing with that, we're going to do actually in reality, where have I put the chuck? It's over there. You put your chuck on the lathe. You put your new piece of work on. Now I've got a bit of ash, nothing that big. First thing I need to do with this, before I do anything else, and I will tell you, I could tell you horror stories and fill up another 2 hours of this, of things that people get wrong with this. But if you start this on the wrong speed, it can be really scary. The lathe will bounce around the room. The worst scenario, it will come off the faceplate. And actually, I have had that scenario happen with people when we've heard stories and questions about safety. So try and keep your speed. So I put this on. First thing I would now do, I take the dial down the lathe. I can bring the lathe up slowly. I can control it. This should be interesting. So at the moment we're on first speed. I get away with it on here. Get to there. Woo. Vibration. All right, you get that noise. So that's kind of telling me I'm going just that little bit too fast. Electric variable is fantastic for this. I can drop the speed back down. Manual belt change is harder to do because you've got set positions. Mechanical belt change, before you load it, drop the speed down. Gradually come up a little bit. So that's really important, Ben.
Going back to the belts, how tight do those belts need to be?
Okay, this has got this handle on the top. I can push in it, a couple of fingers. Okay, let's just move the headstock up just a little bit. It's all right, that's better. Ben on there. Okay, just in picture, I think. So leave it for this. That now this is quite nice on here. That goes on. I can push it on. You don't need to be swinging on it. You don't need a metal bar to create more tension. Other things that can cause issues, and this is a lathe I looked at the other week actually for the guys in servicing. If you're playing with lots of things like plastics and you're sanding it, you haven't got extraction, the dust starts to collect in amongst where the motors, the pulleys are, and everything else. It's like talcum powder. So the guy was getting no drive. What's happening? It's slipping on all this dust that's embodied now into the grooves on the pulleys. It's creating slip. So you need to clean those out. If you have a mechanical variable speed lathe with a lever on the front that you move, that wears belts more because the nature of how that works. So it might be the fact you're getting lots of slip at high revs, you need a new belt on it. So things like that can play a real part. Shouldn't need to go putting loads and loads of weight on it. All right. If you're getting a little bit of slip, now my lathe at home, I can push the motor down gently, tighten the belt up. All I want to do. Don't need to go forcing it, dragging it down too much. All right. So hopefully that's answered that. Okay. Rod adapters we've done. Getting vibration. Now, first nature of what we're getting vibration with, and we've just done a little bit for you. We know if we put this on, I get vibration there. Why? Why do we get vibration? So first thing then, let's bend down to here. This is wood. It's a natural material. Metal, that's a manufactured thing. It has an even density all the way around it, through it and everything else. A few of the engineers can dispute this, but that's a lot more even than what I've got on here. Now my piece of ash on here has different characteristics just in amongst this, and I picked this because it's beautiful to show you what we've got here. You can see the color change, nice brown line, sapwood near the outside of the tree. Out here, dark a bit, is the heartwood. Grain direction, cross grain. There's your dark. This dark stuff is actually dead material. It's clogged with mineral deposits out the soil. The white is the sapwood, was the living part of the tree carrying the nutrients up and down that tree. The brown weighs more than the white. It's clogged with mineral deposits. So that creates a natural imbalance even before I've started. So I have to try and control that, and speed is one way of doing it. We've got a nice piece of laburnum, exactly the same thing. You can see the white and the dark. That gives a good highlight of different densities. So that plays a real part in what's going to happen with our bowl. Some of you will say, I get vibration when I'm cutting. So first thing, let's just have a quick go, pushing time, look. Bowl gouge, what should we go with? Love that. Tool rest, got down there. Look at them. Lock it down, check things are clear. Now I'm going to use bowl gouge, not roughing gouge for this. Speed down a little bit, just got to that bounce point. I can dial it down, so now I'm down to 1,000. We were up to 1150. I put my gouge on, I make contact with the back bevel, I roll it, we can start to cut. I know I'm a little bit off the round, how I cut it. Push across, fingers doing the work, this hand gripping on there. So first thing really on this, to get it round, I'm using the side ring of the gouge. I've got the handle down on my hip, my left hand pushing it across, and we want to get it round. Coming along, nearly there. Down to a diameter, clean cylinder. Just going to bring the tailstock back out of the way, put that in just to make things a bit more secure. Help reduce the vibration, good technique to do. Okay. Get you try to understand what's happening with a bit of wood. I have a bit of tulip wood on here. You can see the grain direction, just going to try those running that way. Okay. Sapwood, heartwood, so side grain. End grain, all right, so I'm going to put an E, an S, S, E. So side, end, okay. Now, play with your hand plane, come down here, plane it up really easily. Less resistance going with the grain fibres. You come here, come across the end grain, a little bit harder, more resistance, different density, even though it's the same piece of wood. So on our bowl that we've got on here, we have exactly the same scenario. Our grain, at the moment, I can do there. Up, down. Ben's going to change thing in a minute. S, E, S, E. Okay? So we have side grain, end grain, side grain, end grain, coming round at 900 RPM. So we've got different densities. Even with that, so we've got a different density between the heart and sapwood, but then even between end grain and side grain. So on here I can use my gouge, come across, cut nicely, take the corner off. Now if I need a cutlass, go back to there. A couple of things I can do. Get your tool rest in a little bit more. Cut down the leverage, that can help you. Speed, I can come up a little bit now, I've made it round, it's going to be good. Now, this will give you a scenario. Left hand is support. Don't need it there as long as I'm pushing the right direction. Getting a bit of rattle because I'm holding on a screw chuck, taking quite a chunky cut. My left hand doesn't need to do anything as such. It's a help, a support, a guide. My right hand is pushing the tip of the gouge in the direction where I want to go. Out here. Okay, in line with that finger's going. It'll cut freely as long as it's sharp and I don't push too hard. Next thing I can do, I can hold the tip of the gouge. It's not mega hot. I've got a clean finish on here. What happens if we do the other thing then? First thing then, strength thing. If I push with the gouge, hoping it sounds different. A lot of weighting behind the tool. I'll tell you, it smells different. So I'm trying to force it to cut. So you can hear a difference. Now, Ben, do you want to hold the end of the chisel for me now? Okay. Ha ha ha. Right? That's hot. Okay? Now, if you push too hard into the workpiece, you're going to cause a vibration. So, I'm getting bouncing. You can hear it? That's because I forced the gouge to cut. If I can make it cut freely and easily and not force it, no bounce. Okay? So the scenario with that sort of thing, if you start trying to force the chisel to cut and you put too much weight behind it, it's going to get incredibly hot. It's going to bounce. It's not the lathe bearings. It's the aspect you're bouncing off of those hard and soft fibers. Okay, Ben.
So a question here from Robert. He has the AC 370 lathe. What's the largest Axminster chuck that he can use?
Which is the 8370, Ben. Okay, let's have a think.
So I think it's the long bed one over there.
So the red one, benchtop. So 100mm chuck would be good. Okay. If it's got a 33 by 3.5 spindle, which I think it has, that's okay. You could go up to the 114 chuck. Now, the reason I say that, okay, so if it's a 33 by 3.5 spindle, go up to the 114mm, all right, go with that as a chuck. If it's the inch 8 spindle, I would go 100mm chuck, all right. The reason really being I say go 33mm is the fact that if you change your lathe a few years down the line, whatever chuck you've already got for that little lathe, you'll be able to take to your bigger lathe. And most people, when we start off with this, we start in a small lathe and it gets bigger. All right, so I'm trying to give that scenario that you could take that lathe with you. All right, my hand's a little bit sore now. That was hot. Now, I'm going to upset a few of you. This is Ben sat here laughing because he knows what's coming. This is not engineering. Okay, it is very different than playing with an engineering lathe. First of all, you hold the chisel. On engineering lathe, you wind things. So you're bound to get a little bit of run out on your piece of work. Wood fibers also react when they're cut. They spring back. So they release tension. So yes, you can get different wall thicknesses. I did a thin bowl about 6 months ago as a demo. We had to sand it in stages to get down to that equal thickness. If I cut all of the bowl and then I sand it, it shrunk across the width before I finish it. Then I sand it. Yes, I get an indifferent, I get a different thickness. So things like that to think about on what's happening. So if you're in, the engineering background, not going to help you with this. It's very different. I can remember having this with a conversation with a guy years ago and bluntly saying, can you actually hold and stand next to the lathe and hold your chisel on your wooden floor in your shed and you breathe and you can hold it within 3 thou, can you? And you're holding it and cutting. It's not going to happen. So think about that sort of scenario of how and what is happening with the workpiece. Okay, Ben, go on.
So a question from Frederick. He's asking why some tools have the black coating. Surely if the steel is black coated, that wouldn't help dissipate the heat.
When we did the craft range, they wanted to kind of give them an identity. So these have a black. This is, I think, a chemical coating from memory. But you can see where we've done stuff on here. We can buff the edge. Not going to affect it too much like that. It's quite a thin coating as well, but it was really just for an identity, I think, Frederick. All right. There are a few other tools like that. Sorby do a range of tools that have a gold color. They have a titanium nitrate coating from memory. That's a harder wearing material. So that's about actually having the plated surface on the top. That's a harder wearing material right on where the cutting edges might work. Okay, but different tools do have different things. But the black, from what I know, was really about the fact of that's what we liked. Actually saved a bit of time with them polishing as well. So it's about trying to maybe cut the cost down instead of having to polish the steel up totally. You can have a black coating. Just want to look at this one. This causes issues. Tailstop. Ben, where do we come to on 2? Yeah. Let's have a look. Now, if I wind the tailstop back, we're not going to get this all done today, but we're doing all right. Okay. How many of you have done this? I've come back and then I can't move it. Locked it up. I've even had this with new customers, so they suddenly can't get, how do I move it? First of all, every tailstock to wind the barrel forward is clockwise. All right, I've never seen anything different, so it is clockwise. Easiest way of doing this, knockout bar. I thread it through the metal handle, right in where the nut is. So I can move it. Okay? But that's an easy way of doing it. Again, it's not involving taking a hammer to it. So I get it locked in underneath the handle, push it down. And that's about trying to give you rotational force to control that. Quick and easy, simple one, just to give you quick things on there. So let's have a quick go through. This one I want to do. I'm going to take the back out. I'm going to change the chuck, but I'll take the bit of wood off first. Other favourite comment that we get lots of from dealing with people. The chuck jaws don't run true. All right. So why and what's happening? I'll put the chuck on there. I'm going to bring the headstock up a little bit again, just looking on the camera we got there. If things aren't running true, where do you need to look at? First of all, and it is possible occasionally, we've got a lot better of how we make our jaws and everything. If I put the lathe on, I put the, say, bigger chuck on. First thing I would look at, Ben, can we go to 3, please? Just on there, the back of the chuck runs true. The body material, I can look at the line where the back plate goes on. I can look at it. Now, everything runs true coming up through this way. On here, if I put my pencil on here, I get a little bit of bounce. And it doesn't look like the jaws run 100% true. Let's see if I can zoom you in a little bit. So you might get a little bit of wobble. Why? And it does throw people immensely. And we get people say, the chuck's not running true. And they send us a little video with the jaws in position, with a pencil on the side, and it'll be hitting the pencil. First thing, the jaws, when they're made, are a continuous circle. It's one of the blinks. I got this from today from engineering, so I put the same size jaws on here. Get your holes, we quarter them. We take about 1/4 of an inch out. So I'll wind this back out. Just go to 2, Ben, please. If you look at the jaws there now, you've got a hole, a slot. I get a pencil in here. That's the same size. So when we cut the jaws, they take about 1/4 of an inch out. That gives them movement to close down. All right, so with it being closed, if I can find the pin location for the, that's it. You look at that on there, so Ben, and that one. What looks more circular? Okay, that one. So why? Because we've come away from that true circle where there's that material gap to close down. So if I'm going to take this back up to here, I can lay that on the top. I'm going to give you a quick and easy access route to this. You should have about a pencil gap in between the jaws. That's now a true circle. The minute I deviate away from that, as in expanding or contracting, closing down or opening in, expanding into a bowl or gripping down the center, you lose that a little bit. So it will wobble a bit. The jaws can't bend just because you've decided you want to make a different diameter. So your best diameter you can aim for, and this is any chuck in the world, is the diameter where those jaws are machined as a true circle. That's optimum grip. The minute we start deviating away, so we close down, you're going to grip on certain points of those jaws. So it's worth thinking about, and that will give you the effect that now this isn't a true circle. If it spins, we're now going to get a lot more bounce on the pencil, because now come away from that true circle. Doesn't show it too well on here. I'm going to get quite amazing. We've got no gap, but we're actually getting a bit of bounce. If you visibly look to them, get a bit of wobble. It's tricky to show you on the camera. You can probably see it. I think most of you might have played with that a little bit. Okay. I think, Ben, because we've done most of it, we've got a few things to go, and I'll pencil it in. We do another session along these lines. Okay. Any more questions from you?
There's been lots of great suggestions and little hints and tips that the guys have been putting in there.
Okay. Have you got more suggestions on different sessions? We'd love to hear. There's things I've still got to do on this one. Like I say, I'll pencil in and try and complete this. Things like Taurus and everything else. So you get the best out of your lathe is really what I'm trying to do. Those of you that are new to this, it's a minefield of an area to come into. How I set my lathe up, where it goes, what do I need as... Okay, even things like extraction and everything else. Frederick, you kind of put a thing about it being cold. I thought someone today might have put a comment about what you use for workshop heating. Okay, there are things. Now, Ben knows I use our NDV 750 extractor. I have an outlet pipe. We can't advertise the fact, actually, the warm air that comes out the motor gets to 47 degrees. I blow it into my workshop. So it's gone through the filters and everything else. So there are ways of heating your workshop without having to have, but things like that can be quite an important part. How your chuck runs, things like spacers, chuck adapters. If you don't have to, don't use them because they will cause more discrepancies. All right, it's worth looking at. Hopefully it's been enjoyable. Giving a bit of an insight of a bit of a minefield and area, setting your workshop up, even things like wooden floors, concrete floors, how you can do insulation, lighting, really important parts, okay? So we will see you again back next week. There's more woodworking wisdom. I hope you enjoyed it. Give us a thumbs up. All right, give us a subscribe. Thank you very much, guys.